Welcome to the deep dive. We sort through the materials you share and, well, pull out the key insights for you.
And today we're diving into AI and design, specifically looking at how data analysis and generative models are changing things.
Right, our source material this time, lecture videos, transcripts, looks like it's from a 2025 Data and Design class shared by the learner.
Exactly, a really fascinating set of resources. So our goal here is to give you a clear picture of how AI is making waves in design through data.
Yeah, analysis, generation, all that good stuff. We'll try to avoid getting too lost in the weeds, technically speaking, but really hit those aha moments.
Okay, so let's get started. There's a lot to unpack.
Definitely. Where do they begin?
Well, the lectures kick off with a project about using data to understand cities better. That's kind of our first big topic, open insights from data.
Oh, I saw that bit. What struck me was the way they combined, like, two dark views. They had the official government data, the top-down view, but then they brought in Google Street View for a bottom-up perspective. It's
Yeah.
like seeing the city from the street level and from, well, the spreadsheet level.
Exactly. And the lecture actually said, so what would top-down data be? Data created by the government, right? Like what is what? I used Google Street View to somehow bring in perception. I brought in perception and tested if there would be a relationship between perception and actual data.
So Street View wasn't just pictures. It was trying to capture feeling, how people see a place.
Precisely. And the big question was, does that feeling, that perception, actually line up with the objective facts about the place?
It makes you think, how often do those things actually match?
Good question.
Yeah.
And they built this incredible data set from it. Imagine a city map, right? Put a grid over it.
Okay.
Then for each little square on that grid, they packed in tons of info.
Mm-hmm.
The 360 Street View scans, what stuff was visible, trees, buildings, that sort of thing.
Mm-hmm.
Distance to the subway, even estimated things like maybe where utility lines might run. Just a really rich picture for every tiny spot.
Wow, that's a lot of data per point. Super useful for analysis, I bet. Which kind of led into that next project, right? The third place implementation from MIT.
That's the one. And just to clarify, third places, those are the spots we hang out in that aren't home or work. Coffee shops, libraries, parks.
Your local haunts.
Exactly. And the goal was to see if they could figure out the character of these places, maybe even predict where they'd pop up just by looking at all that urban data. They found real differences, like between Hongdae and Jeonno in Seoul.
But starting with, what, over 90 types of third places? That sounds like it could get complicated fast.
Oh, absolutely. That was a challenge. Too many categories, not enough examples for some. It led to the model getting too good at recognizing the specific data it was trained on. Overfitting, basically.
Right. It memorizes the test instead of learning the subject. So how do they fix that?
Smart move. They use their own expertise, their domain knowledge about cities, to group things together. The lecture put it like this. So I exercise domain knowledge. You can largely divide it into these three categories, roughly three categories.
Right.
Food, transportation, utility. And the category, rather than just lumping things together, actually has more urban meaning.
Ah, okay. So instead of 90 plus tiny boxes, they made 3 big, meaningful ones. Food, transport, utility. Makes sense. Much cleaner.
And that simplification unlocked the ability to visualize it. They could map out where these different types of activity clustered in a city.
Seeing the spatial patterns.
Exactly. And use that to understand or even predict the kind of third places you'd find in different areas.
And they took this approach to Boston and LA, too. What did that show?
Really different patterns. Boston's downtown, surprisingly, had a lot related to utility. Downtown LA was more balanced, food and transport. Then you look somewhere like Redlands, more suburban.
Much sparser, I imagine.
Yeah, much sparser overall, with commercial hubs really standing out. It just shows how data can, reveal the unique fingerprint of a city.
This is where I think it gets really interesting. The lecturer made a point that these AI tools aren't meant to be crystal balls.
Absolute crucial point. They're insight generators. The quote was something like, machine learning and these kinds of AI are tools that process deep data and give us some insights. It's not that because of this, it's like this, but using this, we check if this is correct, and then exercising our architectural domain knowledge, we continuously develop the design process.
So the AI flags something interesting, asks a question almost, and then the designer digs deeper using their own knowledge. It's a partnership.
Exactly. It prompts investigation. Okay, so another technique they touched on was data interpolation.
Sounds technical, but the example helped, like predicting rainfall.
Right, you only have rain gauges, your data points, in a few spots. Interpolation is basically using those known spots to make an educated guess about the rainfall everywhere else, in the gaps.
Filling in the blanks based on what's nearby.
Pretty much. You can use different metrics, Gaussian interpolation, even neural networks can do this. The core idea, though, is you train the system on the points you do have.
So it learns the pattern and can predict the unknowns.
You got it.
Yeah.
Think about mapping noise levels in a city without putting a sensor on every corner. Very useful.
Okay, makes sense. Then the lectures shifted towards analyzing images, semantic segmentation, and object detection. Let's break those down.
Sure. Semantic segmentation, think of it as coloring book AI. It assigns a category label to every single pixel in an image. This pixel is sky, this one is tree, this one road. Super detailed.
Pixel level understanding. Got it. And object detection.
That's more about finding specific things. It identifies objects, person, car, bench, and draws a box around each one to show where it is.
Finds and locates. And they mention some pretty powerful models out there now.
Yeah, things like YOLO, you only look once, and MetaSam, the segment anything model. They're getting incredibly accurate. The lecturer said, nowadays, very accurate things are available. YOLO.
Yeah.
It detects objects really well. Nowadays, it's even better than this.
So these models are becoming tools designers can just use to automatically pull info from images, like counting windows on buildings from photos.
Exactly that kind of thing.
Mm-hmm.
Or analyzing materials, maybe tracking pedestrian flow. It automates stuff that used to be really tedious. They even mentioned face detection, like for analyzing facial features, maybe for custom product design.
What I liked was how they framed it. It's not just seeing things in the picture, it's transforming the data.
That's the key insight. The instructor said, ultimately, what is it? It's data transformation. It transforms image data into some kind of class data, turning messy visual stuff into organized data you can actually work with.
Okay, so we've got urban analysis, interpolation, image analysis, lots of powerful ways to use AI to understand data. But just having the tools isn't the whole story, is it?
Not at all. The next big chunk was all about critical thinking, data literacy, avoiding the traps. Because you can have all the data in the world and still draw the wrong conclusions.
Oh, yes. The classic correlation versus causation. Easy to mix up.
So easy. The lecture used that fun example. Ice cream sales go up, shark attacks go up. Does eating ice cream summon sharks?
Haha, no, it's the hot weather, right? People swim more A and D, eat more ice cream.
Exactly, the hidden factor,
Yeah.
as the lecturer put it. This actually has a separate hidden value. It's just that when the weather gets hot, people eat a lot of ice cream and they go swimming. This is a correlation, not a causal relationship. That heat is the confounding variable.
And that idea of confounding variables pops up everywhere, like that coffee and heart disease link where smoking was maybe the real issue.
Precisely. Then you've got biases. Confirmation bias, seeing what you expect to see. Sampling bias, drawing conclusions from a group that isn't really representative.
Yeah, they stressed how important that representative sample is. And the sampling problem is very important. You need to know how representative the sample is.
And one bias that always sticks with me is survivorship bias. The WWII airplane example is just perfect.
Oh, right. They looked at where the returning planes had bullet holes.
And thought, okay, reinforce those spots.
Yeah.
Wings, fuselage.
But the statistician pointed out the planes hit in other places, the critical spots.
Didn't come back at all. That's the missing data, the lecture explained. Rather, the truly crucial ones are not in the data. They exploded. The ones that returned, oh, you guys survived, so let's reinforce this part. No, this is the famous survivorship bias. You're only seeing the survivors. Powerful lesson.
Definitely. They also quickly covered a few other things. Multicollinearity, Benford's law for spotting fake data, like with Enron.
Law of large numbers, infinite monkey theorem. Just quick hits to emphasize statistical awareness.
But the main thread seemed to be data isn't enough. You need context. Domain knowledge, like comparing Michael Jordan and LeBron James' stats.
Right, you can't just look at the raw numbers.
Yeah.
Different eras, different roles on the team. The context is everything.
As the instructor said, what's important is to continuously exercise domain knowledge to interpret and understand this data and keep adding meaning to the design process. It's about that human layer of understanding.
And that longevity chair story was a great example. Traffic accidents involving seniors were up. The easy answer? More rules, maybe?
But they observed why. The seniors were rushing because there was nowhere to rest mid-crossing.
So the solution wasn't complicated tech, it was benches. Simple, effective, based on understanding the reason behind the data.
It really drives home the point. Effective data use isn't just about fancy algorithms. It's about defining the data's role, quality, knowing when analysis makes sense.
Not getting obsessed with complexity, and always applying your design thinking and expertise. The lecture summarized it well. Ultimately, what's important is how to apply technical domain knowledge. On top of that, your design thinking is most important.
Okay, so that covers the analytical side pretty well. Let's shift gears to the other big topic.
Yeah,
Generative AI. This is where AI starts making stuff, right?
exactly. Instead of just analyzing what's there, these models learn patterns from data and then create totally new things based on those patterns. The lecture defined it as creating new content from their learning pattern from existing data. If that's the case, then it shows how important data is. Garbage in, garbage out still applies, maybe even more so.
Makes sense. They started with GANs, generative adversarial networks. That's behind a lot of the image stuff we see.
Yeah, genes are foundational. They mention Pix2Pix specifically. Think of it like an image translator. You give it one type of image, say a line drawing.
And it generates another type, like a realistic rendering.
Exactly. Based on learning from pairs of images, sketches and renderings, maps and satellite photos. They talked about training it on furniture sketches or even maps of cities like Manhattan or Seoul to generate satellite views.
Cool. And then 3D generation, that sounded complex. Voxels.
Yeah, basically using tiny 3D cubes, voxels, as building blocks. The AI learns how to arrange them to create new 3D shapes, like digital Lego.
We also heard about style transfer, making a photo look like a painting.
And CycleGAN, which can do image translation even without perfectly matched pairs. But, the big buzz recently is text-to-image. Stable diffusion, models like that.
You type a description and it makes a picture, and these are becoming more accessible for designers to tweak.
Very much so. Fine-tuning is getting easier. The lecture also briefly mentioned encoder-decoder models for creating variations on a theme, good for exploring design options.
Okay, and then the elephant in the room. Large language models, LLMs. They trace the history a bit.
From older models to the big breakthrough, the transformer architecture. That came out at Google in 2017.
What was the key innovation there?
Well, two main things. Parallel processing, so it could handle way more data faster, and the attention mechanism. That lets the model weigh the importance of different words in the input when it's figuring out what word comes next. It helps it understand context much better.
And fundamentally, they work by predicting the next word, right? Based on probabilities learned from massive text data sets.
That's the core idea. It involves breaking text into tokens, then representing those tokens as numbers, vectors, in a way that captures meaning that's embedding.
Yeah.
Words with similar meanings end up closer together in this sort of mathematical meaning space.
And now these incredibly complex models are available on places like Hugging Face.
Yep, it's amazing. Hugging Face is like a giant library. You can find models from Google, like Gemma, models from Korean companies like Kako's Koalai, LG's Xzone, ready to download and use.
And you can specialize them, fine-tuning.
Exactly. Feed them data from a specific field, like computational design. The lecture had that great example.
Oh, yeah. The base model didn't know specific learning resources, but the fine-tuned one did. It recommended that YouTube channel.
Right. It said something like, check out the MJ channel on the YouTube channel operated by Lee Namju. Over 1,300 videos.
Yeah.
The instructor was clear. I didn't teach it this. It learned it and told me. That's the power of fine-tuning.
They also mentioned prompt engineering, getting better at asking the AI questions.
Crucial skill. And RAG, retrieval augmented generation. That lets the LLM pull in real-time info from outside sources, so it's not stuck with just its training data. Keeps it current.
And looking ahead, this MCP thing, large model communication protocol, letting LLMs talk to other software like Blender.
That could be huge.
Yeah.
Imagine telling your design software what to do in plain English. And for experimenting now, there are tools like Llama LM Studio, so you can run these models on your own machine.
Which you actually tried, right?
I did. Yeah, I got Gemma and XR running locally, just basic tests. But honestly, Gemma's performance, even handling Korean, was surprisingly good. It's pretty wild having that capability on your desktop.
So wrapping this up, it's really quite a journey we've covered looking at these lectures.
Yeah.
From AI analyzing cities and images
To generating entirely new designs, text, controlling software, it's a massive expansion of what AI means for design. Much more than just analysis now.
But the constant theme, the thing that
Yeah.
kept coming up again and again.
Is the human element. Data literacy, critical thinking, your own design knowledge. The tools are amazing, powerful, but they're still tools. How you use them, the questions you ask, the context you bring, that's what matters. Understanding the data, spotting the biases, applying your expertise. That's key.
Absolutely. So for the learner, we really hope this deep dive has helped connect some dots on AI in design. Definitely check out those resources, Hugging Face. Maybe try a local LLM tool if you're feeling adventurous. Start playing with this stuff.
Maybe a final thought to leave you with. Thinking beyond the tools themselves. How does all this start to change what creativity even means in design? What does the future role of the designer look like as AI becomes more integrated into the process? Something to chew on.